Okay, very good morning. Today we will discuss about the forward chaining and backward chaining in expert systems. So this is a topic in the second unit of Open Elective of Introduction to Expert Systems. And what is the inference engine that is used in the expert system is the component that is which applies logical rules to the knowledge base to infer new information from known facts. The inference engine was part of the expert system. We already know about it. So it is commonly proceeds in two modes, which are forward chaining and backward chaining. So we are going to discuss these two techniques in today's class. So prior to that one, we need to know about what is meant by horn clause and what is meant by definite clause. Horn clause and definite clause are the forms of sentences of first order logic which enables knowledge base to use a more restricted and efficient inference algorithm. Definite clause. A clause which is a disjunction of literals with exactly one positive literal. See this, the thing to be noted is exactly one positive literal is known as a definite clause or strict horn clause. While horn clause is a clause which is a disjunction of literals with at most one positive literal is known as a horn clause. See, if the clause is having one exactly one positive literal, that is known as a definite clause, and the clause which is having at most one positive literal, that is it should have at least one literal in the positive, that is known as a horn clause. Hence, all the definite clauses are horn clauses only. Next, for example, consider this example. In this example, negation of P, disjunction, negation of Q, disjunction K. In this one literal, that is K is having a one positive literal. It is not in the negative form. That's why it is a positive literal. So it is exactly having one positive literal. That's why which will be categorized as a which clause? Definite clause. Okay. So this expression is logically equivalent to P intersection Q, then K. So what is forward chaining? Now forward chaining is the form of reasoning which starts with input data facts in the knowledge base and applies inference rules in the forward direction to extract more data until a goal is reached. So in the forward chaining, the main thing is we are starting with the input data facts and applies inference rules in forward direction to extract more data until a goal is reached. When decision is taken based on the available data, then the process is called as a forward chaining. Properties of forward chaining are it moves from bottom to up. It is a process of making a conclusion based on known facts or data by starting from the initial state and reach the goal state. It is also called as a data driven approach. Forward chaining is used in expert systems. Similarly, we are having a technique of backward chaining also. A backward chaining algorithm is a form of reasoning which starts with the goal and works backward, chaining through the rules to find the known facts that support the goal. The properties of backward chaining are it is known as a top-down approach, whereas forward chaining is known as a bottom-to-up approach. In backward chaining, it is goal is broken into sub-goal and sub-goals to provide the facts. It is otherwise called as a goal-driven approach, in which a list of goal decides which rules are selected and used. For example, in order to explain about this forward chaining and backward chaining, we will take a small example. So the example is, as per the law, it is crime for an American to sell weapons to hostile nations. Country A, an enemy of America, has some missiles, and all the missiles were sold to it by Robert, who is an American citizen. So we have to prove that Robert is a criminal. To solve the problem, we will first convert all the facts into first order definite clauses, and then we will use a forward chaining algorithm to reach the goal. And later we will also apply the backward chaining algorithm to prove the same thing. So this example is a most famous and simple example. That's why it is chosen. Forward chaining. What are the facts to be converted into first order logic? So the fact is, it is a crime for an American to sell weapons to hostile nations. Let us say that we can assign some variables P, Q, and R propositions. American, assign it as a P. Weapon, assign it as a Q. Cells, PQ, comma R. And hostile, hostile nation, R. Okay. And criminal is P. Okay. So, who is criminal? Criminal is who is selling the weapons to hostile nations. That's why American is assigned as a P. That's why criminal is also a P. Country A has some missiles. Country A has some missiles. So, is it true or not? So, we can represent it by a P owns A. Okay. Next. So, that is represented by P owns AP in conjunction missile P. It can be written in two definite clauses as owns A comma T1 and missile T1. All of the missions were sold to country A by Robert. So Robert is a person. So P missiles conjunction owns A comma P. Then that is sold by Robert P comma A. So here missiles are weapons. Missile is represented as P. Weapons are represented as P. Okay. Enemy of America is known as a hostile. So enemy of P comma America is hostile. Every country A is an enemy of America. Enemy of A comma America. That this can be representations. Robert is an American. American is the thing. So in this one, just these facts will be represented in the block diagram. American, Robert is American, missile is T1, owns country A is owning the missiles. So that fact is represented as A comma T1 and enemy country that is A is enemy for America. This is first representation. Next here uh, and we will apply simple rules. Rule 1 does not satisfy premises, so it will not be added to first iteration. Rule 2 and 3 are already added. Rule 4 satisfy with the substitution P by T1. So cells Robert T1A is added, which infers from the conjunction of Rule 2 and 3, which are discussed in the previous slides. Rule 6 is satisfied with the substitution P of A. So hostile A is added, which infers from Rule 7. So all these can be represented with a simple block diagram. Weapons T1, cells, who cells, Robert cells, weapons T1 to enemy country A. Hostile is hostile nation is A, that is enemy. Here weapons, missiles are weapons here. Who owns missiles? So the enemy A is owning T1 missiles. Enemy is hostile nation for America. American is a robot. So in the next figure, so we can check rule 1 is satisfied with the substitution of this particular proposition. P is robot, Q is T1, R is of A. So we can add criminal robot, which is inferencing all the available facts. And hence we reached our goal statement. So combining these all blocks, that is facts, weapons, weapons are sold by, weapons are that missiles are uh, sold by criminal is robot, and we have to prove that a robot is a criminal. Who sold missiles to that hostile nation? Robot is sold, and here that can be represented as this diagram. Who owns that missiles? That is T1. The hostile nation, that is enemy of America, hostile nation, is having this particular missiles, and robot is American. So obviously, by combining all these, we can prove that robot is a criminal. That is the forward chaining. In the backward chaining, we will use the same example, but rewrite the all rules. That is, we are starting from the goal and continue backwards. So here, what is the goal? Uh, American P, weapon Q, cells PQ, comma R, hostile R, criminal P. Who owns the hostile nation? Owns the missiles. So missiles owns cells. Who sell? These were sold by robot, missile, weapons. Okay, enemy, that is enemy of this particular country is hostile nation P. Enemy of A is America. American is robot. So in this way, we will rewrite. In backward chaining, we will start with our goal and predicate, which is a criminal, and then inferencing further back towards the rules. At the first step, we will take a goal of fact. The goal of fact is Robert is a criminal. That we need to, that is the goal. We need to prove it backwards. Okay. From the goal fact, we will inference other fact, and at last we will provide those facts true. So our goal fact is Robert is a criminal. So, following the predicates in the step 2, we will infer other facts from the fact that satisfy the rules. What are the rules which are what are the facts that are satisfying the rules? The goal predicate, that is criminal, is present with the substitution robot is a P. So we will add all the conjunctive facts below as follows. We can see American, that is robot, is a fact. So it is proved here. So in this way, American robot uh, and hostile nation was sold the weapons by a robot, American. Okay, so this robot sells the missiles to a hostile nation. So at last step, we will extract further the fact missile Q, which infer from weapon Q as it satisfy rule 5. Weapon Q is also true with the substitution of constant T1 and A. So this is the diagram. In this one, we will start with a goal. Robert is a criminal. That is a goal. We will backward just to check the facts. So American is Robert is American. Robert sold the weapons to hostile nation. Okay. So Robert sells that weapons. Robert is selling to hostile nations. So that's why obviously the goal is analyzed so that the facts are to be true. Facts are inferencing towards the goal. That's it. Simple example. So this is last step. Uh, Here we will further expand this particular weapon. The cell robot sells missiles to T1, missiles T1 to coastal nation A. So obviously it was fact. So the differences between forward chaining and backward chaining are these things. Forward chaining starts from known facts. Backward chaining starts from goal and works backward. Next, forward chaining is a bottom-up approach. Backward chaining is a top-down approach. Forward chaining is known as a data-driven inference technique. Okay, backward chaining is known as a goal-driven technique. Forward chaining reasoning applies a breadth-first search strategy. Backward chaining reasoning applies a depth-first search strategy. Forward chaining tests for all the available rules. Backward chaining only tests for few required rules. Forward chaining is suitable for planning, monitoring, control, and interpretation. Backward chaining is suitable for diagnostic, prescription, and debugging application. Forward chaining can generate an infinite number of possible conclusions. Backward chaining generates a finite number of possible conclusions. Okay, so forward chaining operates in the forward direction. Obviously, backward chaining operates in the backward direction. Forward chaining is aimed for any conclusion. Backward chaining is only aimed for the required data. Those are the differences. So this is one of the important topic which you can get mostly in the examinations. If you are having any clarifications or doubts, you can approach me at any time. Thank you.